Hello everyone, welcome to Civil Engineering Realities. So today we will be discussing about nominal mixes. So what are nominal mix? A nominal mix is a basic concrete mixture with a predetermined ratio of ingredients that's used for simple construction projects. So what purpose it serves? Nominal mixes are used for less demanding project that does not require high durability. They are commonly used for small scale construction such as walkways, patios, and floors. Their ratios varies. For example, for M10 to M25, the grades of concrete are called as nominal mixes. M10, M15, M20, and M25 have different ratios. Today we will be discussing about M10. 1 is to 3 is to 6 is the ratio of the concrete mix design of M10. You can visit our website Civil Engineering Realities www.civilengineeringrealities.com. So let us discuss the topic today. Calculation of the cement, sand and aggregate for M10 only. Let's calculate for M10 concrete design mix. As we know, IS 456 gives the value of the M10 as 1 is to 3 is to 6. Here you have to remember 1 stands for cement and 3 stands for sand and 6 stands for aggregate. Sand here is a fine aggregate and aggregate that we use here is a coarse aggregate, usually of 20 mm. The total volume will be cement plus sand plus aggregate, that will be 1 3 and 6. So here the total volume will be 10. Now we have calculated the total volume as 10. What we have to find here for that calculating the design mix of M10 grade? We have to find four things. Firstly, volume of a cement. Secondly, volume of a sand, volume of aggregate and water. For 1 m cube we are finding 1 m cube of concrete. So let us find the volume of a cement for M10 grade of concrete. Firstly, I have assumed here 1.54. So what is 1.54? As we know that when we pour wet concrete during concreting, it hardens after certain standard time. In view of this, it was designed by the civil design engineers to take a certain form of safety factor from 1.54 to 1.57. I have assumed here 1.54. So we can say volume of dry concrete is equal to 1.54 times volume of wet concrete. Therefore, the total volume of concrete required is 1.54. Now we will calculate. Let me rub this first. Now we have to find the quantity of a cement. That will be cement divided by the total volume. The factor we have assumed 1.54. Cement has the ratio 1 from the standard design mix of M10 1:3 is to 6. So this value you have to apply here, and the total volume you have observed here is 10 into 1.54. So the quantity of a cement will be 0.154. As we know, one bag of cement weighs 50 kg. If we have to calculate a total number of bags, for that you have to use volume of one bag of cement. You should know the value of one bag of cement volume. That will be 0.0347 m cube. For getting the total number of values, you have to divide the quantity of the cement divided by the volume of a one bag of cement. So you will get 4.52 bags for M10 grade of mixed design. Hence, we require 4.52 bags for 1 m cube of concrete. So firstly you have calculated now volume of a cement. Now secondly, similarly we have to calculate the volume of a sand. Quantity of a sand is equal to sand divided by the total volume into 1.54. The value of the sand from a ratio will be 3 divided by 10 into 1.54, that is equal to 0.062 m cube. I have calculated these values. So for 1 m cube of sand, the density of the sand varies for various kinds of sands. So we have assumed 1600 kg. For 0.626 m cube of sand, we have to multiply the density with the quantity of the sand. That will be the required quantity of the sand for 1 m cube of concrete for M10 grade. So we require 739 kg of sand for 1 m cube of concrete. Now volume of aggregates. You may certainly know that we use 20 mm for aggregates. It will be mixed with 10 mm and some small amount of tiny particles. Usually we take 20 mm for aggregates. Similarly, for this also, the quantity of the aggregate will be calculated aggregate divided by the total volume into 1.54. As you know, the aggregate value is 6 divided by 10 into 1.54. You know the value of M10 design mix is 1 is to 3 6 is to 6. This value is this for aggregate. So after the calculation we got 0.924 m cubes. 1 m cube of aggregate, the density of aggregates varies from 10 mm and 20 mm. So we have assumed the bulk value of the aggregates as 1500 kg. For 0.24 mm cube of aggregates, we have to multiply the density of into the quantity of the aggregates we have got. So it will be 1 is 1386 kg. So we require 1386 kg of aggregates for 1 m cube of concrete. Water required for 1 m cube of concrete. As we know, the water cement ratio varies from 0.35 to 0.5. Let's assume water cement ratio of 0.45 is a stable water cement ratio. We use this water cement ratio most certainly because we have to check the slump of the concrete. It should be maintained, it should not be so much wet so that our concrete will not be in good shape. It should be workable. Water required for 1 m cube of concrete. 226 into 0.45. You may be confused here where this value comes from. So this is the 0.45. We have to assume this. I will tell you the value of 226, how it comes here. As you know, we have calculated the number of bags for M10 grade is 4.52 bags. Here I will show you 4.52 bags. So 4.52 bags into the one bag of cement weighs 50 kg into 50. After you will calculate this, you will get the value 4.52 into 50, that will be 226. You will multiply 226 with the assumed water cement ratio, so we'll get the quantity of water required. It will be 102 liters. Hence 102 liters is required for 1 m cube of concrete. So thank you for your time.